A plastic bottle. It will outlive you, your children, and even your great-grandchildren. At least that's what we're told. 500 years. That's supposedly how long plastic takes to decompose. Imagine this. If a knight in the 15th century had thrown away a plastic bag, it would only now be starting to decompose. When Columbus was discovering America, that bag would still be lying there completely intact. This number, 500 years, you've seen it everywhere. In the news, on social media, in school textbooks. But have you ever stopped to think, where did this number actually come from? Did someone actually wait 500 years and check? Obviously not, because plastic has only been in mass production for about 70 years. So what's behind this claim? Science? Or a beautiful myth? Today we're going to pick this claim apart piece by piece. We'll conduct a real investigation and find out what science actually says. Is it true that plastic takes 500 years to decompose? Myth or reality? Let's find out. To understand where the myth came from, we need to go back to the beginning, to the moment when plastic first appeared. In 1907, Belgian chemist Leo Baekeland created Bakelite, the first fully synthetic plastic. By the 1950s, plastic had become a symbol of progress. Cheap, lightweight, practically eternal, it seemed like a miracle, and production began growing at an incredible rate, from 2 million tons in the 50s to more than 400 million tons today. But by the 70s, it became obvious. This miracle had a dark side. Plastic wasn't going anywhere. The environmental movement was gaining momentum. People started asking questions. What will happen to this waste in 100 years? In 200? Scientists started their research, but they ran into a fundamental problem. You can't run an experiment that lasts 500 years. Nobody lives that long. That's when organizations like the National Oceanic and Atmospheric Administration, NOAA, started publishing estimated data. Notice the word, estimated. Not exact, not experimentally confirmed, but calculated based on models. But when this data reached the media, all the caveats disappeared. Only one nice round number remained, 500 years. Social media picked it up instantly. Infographics, reposts, viral posts, and the number became a fact. It made its way into school textbooks, into documentaries, into politicians' speeches. Documentaries like A Plastic Ocean amplified this message many times over. The famous infographics appeared. Banana peel, 2 years. Paper, 5 years. Plastic, 500 years. And now, every person on the planet is convinced that plastic decomposes in exactly 500 years. Period. But science doesn't work that way. Science doesn't like round numbers and absolute statements. Even the US Environmental Protection Agency, the EPA, uses the phrase, may take up to 500 years or more to decompose. See the difference? May take and takes are completely different things. It was a classic game of telephone. A scientific estimate turned into an absolute fact. A cautious scientific statement became a screaming headline. And here we are. So let's start with the arguments in favor. Why might this number actually be true? Argument number 1, the chemical structure of plastic. Most plastics are polymers, long chains of molecules that don't exist in nature. These chains are incredibly strong. The bonds between carbon and hydrogen atoms are very stable. In nature, organic materials decompose because microorganisms know how to digest them. With plastic, it's a completely different story. Bacteria and fungi over millions of years of evolution learned to break down wood, leaves, and fruit. But plastic is a new material that's only a few decades old. Microorganisms simply haven't had time to evolve to feed on plastic. They don't have the necessary enzymes. Argument number 2, direct observations. We see plastic on the ocean floor that looks like it was thrown away yesterday. The famous garbage project by archaeologist William Rathje in Arizona proves something astounding. Rathje excavated landfills and found 30-year-old plastic packaging that looked brand new. Labels were still readable, colors were preserved, the plastic had barely changed at all. Argument number 3. Ultraviolet light, plastic's main enemy, doesn't penetrate deep underground or into deep water. And that's exactly where most plastic waste ends up, in landfills, buried under tons of earth. Argument number 4. the Great Pacific Garbage Patch. Its area is about 1.5 million square kilometers. That's larger than the territories of France, Germany, and Spain combined. Plastic that's decades old is floating there, and it hasn't gone anywhere. Birds, fish, and turtles die by mistaking this plastic for food. This isn't theory, it's reality. Argument number 5. Accelerated aging laboratory tests. Scientists place plastic in chambers that simulate years of environmental exposure. The results are extrapolated over hundreds of years. And these extrapolations show, yes, plastic needs centuries. Since 1950, humanity has produced 8.3 billion tons of plastic. Just think about that number. Of that, only 9% has been recycled. 9! The rest is in landfills or in nature. If plastic really does take centuries to decompose, that means virtually all plastic ever produced still exists. Argument number 6. Some types of plastic are particularly resistant. PET, polyethylene terephthalate, used to make bottles, is extremely stable. It's resistant to water, bacteria, acids, and alkalis. That's precisely what makes it the ideal packaging. At the bottom of the ocean, where there's no light and little oxygen, plastic can last practically forever. A plastic bag was found in the Mariana Trench at a depth of nearly 11 kilometers, the deepest place on Earth. Plastic has been found on the summit of Everest at an altitude of 8,800 meters, and even in Antarctica, one of the last untouched corners of the planet. In summary, chemistry, direct observations, and lab tests all suggest the 500-year claim has serious grounds. But now let's look at the other side of the coin, and this is where it gets really interesting. Counter-argument number 1, and it's fundamental. No one has ever observed plastic decomposing over 500 years. The first synthetic plastic, Bakelite, was created in 1907. It's only 118 years old, and the PET bottle only appeared in 1973. It's only 52 years old. So the 500-year figure is a forecast, an extrapolation, a prediction based on models, not an observation. And extrapolations are unreliable things, especially when you're trying to predict a material's behavior centuries into the future. Counter-argument number 2. Environmental conditions radically affect the rate of decomposition. But here's the key point. Plastic doesn't decompose in the classical sense. It fragments. It breaks down into smaller and smaller pieces, microplastic, particles less than 5 millimeters in size. This is a critically important distinction. Decomposition means the material returns to nature. Fragmentation means it simply becomes invisible. When a log rots, it turns into soil. Fungi and bacteria break it down into molecules that nourish new plants. Plastic doesn't turn into soil. It turns into trillions of tiny plastic particles that penetrate everywhere. Counter-argument number 3. Not all plastic is the same. There are dozens of types of plastic, and they all behave differently. A thin polyethylene bag in the sun can fall apart in 20 to 30 years. It becomes brittle and crumbles. But a thick PVC pipe underground could last 1,000 years. Nobody knows for sure. Counter-argument number 4. Environmental conditions change everything. Temperature, sunlight, humidity, oxygen, everything plays a role. On a hot tropical beach under the blazing sun, plastic breaks down significantly faster. But in the Arctic permafrost, it can last practically forever. Cold and darkness are its best friends. Counter-argument number 5, and it's the most surprising. Nature is beginning to adapt. In 2016, Japanese scientists discovered a bacterium called Ideonella sakaiensis. This bacterium was found at a bottle recycling plant, and it can actually eat PET plastic. It produces a special enzyme, PETase, that cuts polymer chains into small fragments, which the bacterium then digests. And this isn't the only example. Wax moth larvae, Galleria melanella, are capable of eating polyethylene. Mealworms, larvae of the beetle Tenebrio molitor, can feed on polystyrene, ordinary styrofoam. And in 2017, a fungus called Aspergillus tubuensis was discovered in Pakistan that breaks down polyurethane. Nature is evolving, it's learning to deal with plastic. It's not happening overnight, but the process has already begun. Scientists at the University of Portsmouth even improved the PETase enzyme, making it 20% more effective. And in 2020, they created a super enzyme by combining PETase with another enzyme. It breaks down plastic 6 times faster. The company Carbios in France is already building the world's first plant for enzymatic recycling of PET plastic. Counter-argument number 6. Biodegradable plastics already exist. PLA, polylactic acid, is made from cornstarch. In industrial composters at 60 degrees, PLA decomposes in just a few weeks. Though there's a catch. In a normal environment, in the ocean or a regular landfill, PLA behaves almost like regular plastic. Counterargument number 7. Plastic is affected by several processes simultaneously. Photodegradation, destruction by ultraviolet light. Oxidation, a reaction with oxygen that slowly breaks down polymer bonds. Mechanical degradation, waves, wind, friction. All of these work together. The actual range of plastic decomposition is not exactly 500 years. It could be anywhere from 20 to 1,000 years depending on the type of plastic and conditions. A thin bag in bright sunlight, 20 years. A thick PVC pipe underground, possibly over 1,000. In summary, the 500-year figure isn't a lie, but it's not a precise fact either. It's a very rough average for conditions that can't be generalized. And now we've arrived at the main question. Plastic takes 500 years to decompose. Myth or reality? The answer, as is often the case, isn't black and white. Our verdict? Partially true, but with enormous caveats. The truth is that plastic really does decompose incredibly slowly. This isn't a myth, it's a real problem. But the exact figure, 500 years, is not a scientifically proven fact. It's an estimate, and a very rough one at that. 500 years is the middle of a range that's actually enormous, from 20 years to over 1,000. Everything depends on the type of plastic, environmental conditions, the presence of sunlight, temperature, and even microorganisms. But here's what's really important, and it's even scarier than 500 years. Plastic doesn't disappear, it just becomes invisible. It turns into microplastic that penetrates the food chain. Microplastic has already been found in our blood, in our lungs, in our brains, in our organs. According to the University of Newcastle, every person ingests about 5 grams of microplastic per week. That's the weight of a credit card. So the real answer is more complicated than just 500 years. Reality is worse and more tangled. Let's sum it up. Myth: plastic decomposes in exactly 500 years. Reality: the exact time is unknown, but it's very, very long. The key takeaway: it doesn't really matter whether it's 500 years or 300. What matters is that every piece of plastic ever produced still exists in one form or another. But wait, we promised an unexpected twist, and here it is. In 2019, scientists made a discovery that shook the scientific world. Microplastic was found in rainwater. It falls from the sky. Literally, microplastic was found in rain that fell over the Pyrenees Mountains, far from any civilization. Tiny plastic particles rise into the atmosphere, travel with winds, and fall down with precipitation. This means you're breathing in microplastic right now, with every breath, no matter where you are. In 2022, microplastic was detected in human blood for the first time, in 77% of those tested. And in 2021, Italian scientists found microplastic in the human placenta. It reaches unborn children. According to the World Wildlife Fund and the University of Newcastle, each of us consumes up to 5 grams of plastic per week. We drink it with water. Microplastic has been found in 93% of bottled water and in 83% of tap water. We eat it with sea salt. Studies have shown every kilogram of sea salt contains from 600 to 10,000 microplastic particles. Microplastic has been found in honey, in milk, in beer, in practically everything we consume. German scientists found microplastic in 24 brands of beer. Every bottle contains up to 200 particles. And here's the final blow. In 2014, geologist Patricia Corcoran discovered a new type of rock in Hawaii, plastiglomerate, melted plastic fused with volcanic rock, sand, and shells, creating an entirely new material. Plastic has become part of Earth's geology. Scientists are already proposing to call our era the Plasticine, by analogy with the Pleistocene, because plastic will become our main geological marker. Millions of years from now, if someone studies our layer in the rock, they won't find dinosaur bones. They'll find plastic bottles and bags. According to the Ellen MacArthur Foundation, by 2050, there will be more plastic in the ocean than fish, by weight. But there's also hope. The Ocean Cleanup Project has already removed over 200,000 kilograms of plastic from the ocean. Scientists continue to improve enzymes for plastic recycling. Perhaps in 10 to 20 years, we'll be able to recycle plastic as easily as paper. Companies are developing packaging from mushroom mycelium that decomposes in 45 days, and packaging from seaweed that dissolves in water in just a few hours. Plastic doesn't decompose in 500 years. That's a rough estimate. But reality is even more serious. It never disappears. It just becomes invisible. And that is our problem right now. If you enjoyed this investigation, hit that like button and subscribe to the channel. There are plenty more myths ahead that we'll pick apart. See you next time!